Alright, welcome back, ladies and gents. This is 1.2. This is the part of the video where we have to start using Desmos. Okay, again, when we talk about regression, you can watch the other video to learn about what regression is. I'm only going to go through how to actually do this in Desmos. Alright, so make sure you at least follow through the other video up until this point, talking about what regression is, and then we'll talk about how to actually do this problem, and then the next problem, which is down here, lists the number of Americans who are expected to live over 100 years old. Okay, we'll do both of those problems, and this piece here was the quick review of graphs. That's in the other video. I'm not going to discuss it here. Okay, so let's get moving. We need to type this into Desmos. Okay, so let's go to Desmos. Remember, Desmos.com. You're going to click on the graphing calculator. And this is what pops up. Okay, I'm going to dual screen it so I can kind of show you what I got to do here. Alright, on the Desmos side, what we're going to do is we're going to hit this plus icon. We're going to hit table. Now that table looks like this table. Wow! And all you're going to do is just type in the first column there. The first column, this is our X's and this is our Y's. Whatever the first column is, this is always X and always Y. Okay, don't get them confused. Alright, so I'm going to go up here to the table. I'm going to type in the numbers. 9, 13, 21, 30, 31, 31, 34. Whoa, I got to hit enter. Haha. 21, 30, 31, 31, 34, 25, 28, 20, and 5. Okay, now make sure that you're typing in, make sure your numbers work good, because if you have one extra number here or one extra number here, like obviously your data is not going to work right. So make sure you type it in correctly. So we got 260, 320, 420, 530, 530. See, this is where you get 420, 530, 560, 550. Don't know why it's going. There we go. 590, let's go, that's a good one. 500, 560, oh my gosh, my enter button's not working on my computer. 560, 440, and 300. Now, these are a bunch of just dots on a graph. Okay, these are a bunch of just dots. Now, how am I going to actually find out where those are? This is the beauty about the table piece in Desmos. There is a magnifying glass here. If you click that magnifying glass, your data will actually appear pretty nicely, I'll go over here, pretty nicely within the graph. If you go over like this, you can actually do that. You can zoom out, you can zoom in if you want to. And then say you zoom in and zoom out way too much, you can always go back and hit that button again, and then now it makes it even nicer for you. Alright? So that's what the data looks like. Now, my question to you is this, okay? If I look at that data, what kind of graph does the data look like? Well, I guess I will do a little bit of the graphing piece. Okay? Linear is a straight line. We have quadratic, which looks like a U. Okay, we have exponential, which looks like it starts off slow and all of a sudden it goes really high, and we have square root, where it looks like the opposite of exponential, kind of. It looks like this. Okay, if you look at this data, it looks as though it's probably a straight line. Okay, because the graphs is going up to the right, up to the right, up to the right, pretty much every sort of data set. Alright, so we're going to use what we call a linear regression. Now, if you had your TI, you can just type in linear regression after you typed in the table, and it would do it for you. Okay, but we're going to do it using Desmos, and we need to be able to type in how to do this. Okay, so this is part of your notes that you are going to need to add. And I'm going to actually make this side bigger so I can show you what you need to type in. And I'll actually go here. Okay. Well, maybe no, I won't do that. I'll just do it right in here. Okay, here we go. Linear. Remember, we said it was a straight line. Here's what you need to type into Desmos in order to actually get it to recognize that it's a linear regression, in order for you, or the computer Desmos, to actually recognize that. So here we go. You're going to type in y sub some number. So there's a number here. Okay, this is a tilde. This is above your, next to your 1 key. You hit shift and next to your 1 key. Tilde is something like this is like, think about this as goes over like the N in Spanish, like this is like an ñ or something like that. So it's called a tilde. And then what's the formula for linear? Well, technically what is y equals mx plus b, right? So this y is now y sub some number. I'll tell you where that number comes from. The equal sign is that tilde. The m doesn't change. The x is that same sub number, and then plus b. Okay, we're going to use that right now. So make sure you have this written down, because I'm going to erase it right now, and I'm going to go back to Desmos. All right, so let's talk about that. I need to type that in here. So I need to go to the next row here. I'm going to type in y, and I need a sub some number. So you have two options. The first option here is you can open the keyboard, and you can hit ABC. Don't know why it's over here, but there it is. If you hit this A sub B button down here, it gives you a subscript. The number that is going to go as a subscript is always what this number is here. Sometimes, when you do this multiple times for different types of formulas, you might get y sub 4 or y sub 5. So those numbers need to match. Okay, those numbers need to match. All right, so y sub 1. Hit the right key. Now, you need to hit your tilde, which is shift and the key next to the 1. M. Okay, x. And I also need the same number, so x sub 1. So I'm going to hit that AB key again, x sub 1. I'm going to hit the right key, and then remember it's plus B. Okay, plus B. Now, this is where it's cool. This is really the work that it already did. Okay, this is the work for this problem. So what I'm going to do is I'm going to take y sub 1, the tilde m x sub 1 plus b, and I'm going to plug in the m and the b into my equation. So what's going to happen is this. My equation for this linear regression is y equals 11.7313x plus 193.852. This is the equation that this data models. And you can see that black line right there. That's the data. That's the line of best fit. We call it a line of best fit. You might have done this in other classes. Okay? We want to model the data to give us the best value and of how correct all the data points is showing. Okay? So that line is pretty good. Okay? Pretty good. All right? So we're going to use this data now, or this equation. Let me do this. We're going to use this equation to answer the rest of all of this stuff. Well, how do I do that? What do you mean answer all the rest of this stuff? Well, I am going to use that equation to answer predict that and the predict this. Okay? So it says predict the calories of the grilled cheese burger that has 79 grams of fat. Holy cow, that's a lot of grams of fat. Well, which one of these is grams of fat? That is the X column. So I'm going to take my equation, y equals 11.7313. I'm going to multiply that by 79, and I'm going to add 193.852. Now, I'm not going to do that. You can calculate using a calculator, okay? So multiply and then add this, and you'll get your answer. It's going to be some crazy amount of calories, okay? Some crazy amount of calories. Now, the second question, it says predict the fat grams of an 800-calorie sandwich. So because that's calories now, that's the y value. So I'm going to bring up here And I'm going to say it's 800 equals 11.7313x plus 193.852. And then I'm going to subtract and then divide by 11.7313, and I get x is equal to something. And that something is how many fat grams are in that sandwich. Okay? So in this case, we had a linear regression. Linear regression. What happens if we have something else? So hopefully you got all this because I'm deleting it. Well, the next one we got to work on is quadratic regression. Remember, a quadratic looks like a U. In real life, we don't really have a U that looks like this. Okay? In real life, we deal with U's that are upside down. Alright? Think about throwing a ball or shooting an object into space or a rocket ship or something like that. Okay? We gotta come down. Alright? So, quadratic regression looks like an upside down U almost all the time. Sometimes it will look like this, but not real life stuff. Anyway. Here's how I do this one. Again, my equation is y sub some number, whatever that number is. Again, we talked about that before. The tilde, or this is actually the math term, I think it's called a twiddle. Twiddle! It's called a twiddle, so but tilde is fine too. Now, what's the general form of a quadratic? Y equals ax squared plus bx plus c. So we got to take this general form and rewrite it. So ax sub some number and square that same number plus bx sub some number plus c. This is your quadratic regression model. I'm drinking a Monster here at 10:18 p.m. I'll fall asleep by 11. It's fine. Okay? All right, so this is your quadratic regression. I'll have others here as well. The exponential regression. I don't know if we'll have one, but we might. I can't remember. Regression. This one is y sub that number, twiddle, a times b to the x sub number. So b to the x sub number. So b is the number to the variable, like to an exponent, x sub that number. Okay, that's your exponential regression. I'm not going to do square root because we won't have one. I know that for a fact. I will do a cubic just because I think we might have one of those in your practice or somewhere. So this one here is a little longer. This is y sub some number, twiddle, ax sub some number cubed. So this is a 3 plus bx sub some number raised to the 2 power plus cx sub number plus d. So that's a longer one. You have to know all of these, okay? Leave them in your notes, but you have to know how to enter them into Desmos. And so now, hopefully you have that, because, or you pause the video, right? Because I'm going to go on to the next problem, which is this one here, the table below and all of this good stuff, okay? So, here we go. Let's go to the videotape. Let's go to Desmos, okay? Now, if you went to Desmos again on a different day, maybe tomorrow or later on, these x sub 1 and y sub 1 might still be there, okay? Like, they might actually let you do that. But now, I'm going to make a table, and you're going to see that this x sub 1 and y sub 1 is there. So that stayed the same. That's great. Sometimes they don't. Sometimes this number is a 2, and this number is a 2. Okay, so I'll use this right here. Sometimes it'll change, so I'm going to show you how to do that and deal with it. Okay? Here we go. Let's type this in. We get 1994. Oh my gosh, I can't type. That's supposed to be 1994. 1994. Oh, I gotta delete. Delete. 1994. 1996. 1998. 2000. 2002. 2004. Okay. Fantastic. Now, I got all those. Now let's write our other ones down, right? So we get 50, 56, 65, 75. This thing is double tapping my enter buttons. I don't like it. And then it doesn't tap when I need it to. 75, 94, 110. Okay? Remember, how do we get that nice graph to appear? We hit this magnifying glass. Boom. Now look at our graph. Now look at our graph. Okay? Now, what does that kind of look like? Well, hopefully we can probably assume that it's one of the couple options that we did. Now, what I did, okay, as I zoomed out a little bit, okay, we can see that it has some sort of curve to it. It looks like it's got a curve. It doesn't look like it's a straight line. It looks like it's about to curve a little bit, okay? So I'm going to call this a quadratic. Now, this one here is a little bit more complicated because it's not a clearly defined graph. Like, it does kind of look like a curve, but it could look like a straight line, and it maybe could look like exponential. Okay, we have to go with your best gut. Always start with the easiest and then work your way up to the more difficult. If you're automatically assuming this is exponential, then, I mean, let's not do that, okay? Let's go to linear. Well, it doesn't look like linear. It looks like it's got a curve if I keep zooming out. And let's go to quadratic next, okay? So let's do that. So how do I do that? I'm going to go to number 2. I'm going to type in my equation. Remember, my equation was y sub a number. So remember, I got to go down here. Okay, sub what number are we typing in? 2. In this case, it's 2. Make sure I hit that shift key with that twiddle. Twiddle! It just sounds fun to say. Okay, and then I'm going to now do AX. Remember, it's AX. Let me write it down here so we can see. Remember, it's y sub number, whatever that number is. In this case, it's 2, so I'll use 2. Twiddle ax sub 2 squared plus bx sub 2 plus c. This is what I have to type in. All right, how do I do that with all of these lower, like a subscript 2 and a superscript 2? Here's how you do it. You do the a sub b first. You make the subscript. Okay. Then we go back and we make it a squared, just like this. So now it looks like there's a 2 on top of a 2. 2 plus b x. I got to go back and hit that ab sub 2 plus c. Now you can see that this kind of graph kind of goes through almost all of these points. Okay, almost all of these points. Here's one way where you can kind of tell if it's linear, quadratic, or something maybe even a little bit more difficult. Once you do your first guess, this r squared, if it's really close to 1, that means I would just leave it there, you're good to go. This was at a 9. This is basically saying that data is 99% compatible. Okay, 99% compatible. So that's good enough for us. Now you might be thinking, well, what happens if I did linear? I'm just going to do linear real quick. Don't do this, but just I'm going to show you what you would get if you did linear. Okay, so y sub 2 twiddle mx sub 2 plus b. See this r squared? This is at 96%. Okay? Maybe you can get better. That's ultimately what I did. All right? I did better and I got 99% versus 96%. So, obviously this one's better, right? So I'm going to delete the linear one. Okay? Delete it. Gone. So now how do I write my equation? Part 2 of this here says determine the function represents the data. So I'm going to say that is quadratic. The model is going to be y equals, remember, it's ax squared. So a right here is 0.401. 786. Now, if you want to go 3 places, that's fine. So round to 3. Round to 3. Oh, it's a 2, not a 7. 2. Round to 3 places. Okay, if you don't know how to round, go back to 3rd grade. 0.402x squared plus, minus, because b is negative, 1600.28x. I'll do it down here so we can actually get a better reading down here. Y equals 0.402x squared minus 1600.28x. And then this here is a big number. Plus 1.5935 times 10 to the 6. That's okay to leave it that way. Okay, that's okay to leave it that way. So that's your equation. That is your equation. Fantastic. Fantastic. Now, you might be thinking, that's kind of crazy. Like, those numbers are kind of large. 1600. This number here is actually, I don't even know. I think it's like 1 million or something like that. Okay? That's crazy big. So here's the deal. Here's what we can do to make it smaller. Whenever you're dealing with numbers in the year column, like a year time, that are large, like this, 1994, that's a year. What I can do is I can actually make this smaller, turn it to 0. And then how far is 96 away from 94? That's a 2. That's a 4, a 6, 8, 10. So that's what I'm going to do up here. I'm going to change these to 0, 2, 4, 6, 8, 10. Now, my r squared stayed the same. I'm going to hit the magnifying glass, and now I get my data. My r squared stayed the same. My a value stayed the same. My a value stayed the same. My b value changed now. It's really small. And my c value is such a small number now that I can calculate it a lot better. So I am going to do that. You have the option to do that. If you wanted to leave your answer in 1994, 1996, and leave your answers as those big numbers, you are more than welcome to do that. Just think about this. The next problem, number 4, you would have had to plug in 2010 into x and multiply. Guess how big those numbers would have been. Crazy big. Okay? So it's probably a good thing you didn't actually do that. Alright, so I'm going to erase this and I'm going to write my new answer down. Okay? So 0.402x squared, that stayed. Now it's a plus 2.039x, because I rounded. Remember, this 2 stayed the same. Plus 50.071. Alright? There's my equation right there. Here. Right there. Predict the number of 100-year-old Americans in 2010. Well, how far is 2010 away from 1994? Well, that's 16. So I'm going to take 0.402 times 16 squared plus 2.039 times 16 plus 50.071. I'm not going to do that math. You can do that. The answer's in the other video. Predict when there will be 80,000 100-year-old Americans. Well, what does that mean? Well, this number is already in 1,000. So this is 50,000, 56,000, 65,000, 110,000. So I need to take my y value, and I need to make that 80. And that's going to equal 0.402x squared plus 2.039x plus 50.071. Now, you might be thinking, how in the world am I supposed to find out what x is going to be to give me 80 on the left side? Well, guess what? Desmos can do that for you. Here we go. Okay, here's what Desmos is going to do. I'm going to make a third row. Remember in the last video for Desmos, last section, whenever we wanted a y value to be equal to something, I can just create it right here. Put y equals 80. So that's what I'm going to do. Okay, I'm going to make this y equals 80. and I want to find out where the graph touches that point. And I found it right there. And it says that at 6.458 years away from 1994. So this is a little after, or this is almost halfway, after year 2000. Okay, if I look on the data, this is 75, and then it goes to 94, okay, 2 years later. So 6.5, so this is going to be 2000 in about June or July. Somewhere in that neighborhood is where it's going to, you know, cross over to the 80,000 mark. Okay? That's it for this video. This is to show you how to use Desmos with linear regression, quadratic regression. Okay? Let me show you one thing with exponential regression. This is not for this video, or not for this question, but I'm going to show you how to type it in. Remember, y sub 2, okay? Put the twiddle. Remember, then it's a, b, 2. I got to make an exponent there, to the x, and then I got to make that a sub 2, okay? A sub 2. Now, you're like, well, that's 99.19. This is 99.73. So this one's still even better. Dang! Okay? But this is how you would type in your exponential regression. Okay? I think we might have one problem like that. Not too much. All right? Ask questions the next time we see each other. And deuces my gooses.